Vectors and Mechanics, Further Mathematics, 2024, Paper 2. Question number 15. A particle P of mass 1.2 kg is acted upon by forces F1, F2, F3, and F4. If the acceleration of the particle is 14 meters per second and 240 degrees is the bearing, find correct to the nearest whole number, F4. So first we resolve all the forces. So we resolve all the forces into the component form. So F1 will be 15 sine 90, 15 cos 90, and that will give us 15 0. Similarly, F2 will give us 0 20, and F3 will be negative 15 root 3. Then we resolve the acceleration and the F4 as well. So the acceleration is negative 7 root 3, negative 7. Now we find the net force. According to the Newton's law, the net force is mass times acceleration due to gravity, and that is given as 1.2, which is a scalar, times the acceleration that we found, and that is giving us negative 42 root 3 over 5, negative 8.4. So now we again apply the principle of net force. When we add all the forces that we resolve, it should give us the net force. So F1 plus F2 plus F3 plus F4 should give us what is here. So we have to solve for k sine alpha, k cos alpha, which are the components of F4, the force we are looking for. So we find out that k sine alpha, which is the x component of F4, is negative 14.5492, and k cos alpha, the y component, is negative 2.4192. So we have F4 to be equal to negative 14.5492, negative 2.4192 to 4 decimal places. But we need to leave the answer in the form K Newton alpha degrees. So we convert to magnitude bearing form. So let's find the magnitude of the force. So we can now calculate the bearing, which is alpha degrees for F4. So if we divide k sine alpha over k cos alpha, we eliminate k, and that will give us tan alpha equal this. So we divide this by this, divide this by this. That's what gives us this. And since they are all negative, both the x and the y component are negative, it tells us that it's in the second quadrant. The force is in the third quadrant. So it will be 180 plus, the bearing will be 180 plus tan inverse of this over this, and that will be equal to 261 degrees. Therefore, the force F4 in terms of k newtons will be 50 newtons, and in terms of bearing will be 261 degrees.